Good afternoon, everyone. I'm Michelle Ewan, and I'll be talking about a system for printing high-definition sensors into substrates. So this is an example of a print that's going in progress. And what we're doing with this system is we're directly patterning and embedding sensors into a substrate in a single step. So in this case, we're printing some strain sensors into some spandex fabric. The sensors here are made up of silicone elastomer. This is printed as a liquid, and then it cures into a solid, stretchy rubber. We're able to make that material both conductive and non-conductive, and so we're able to create these capacitive sensing devices right here. The ones that you see right here are for measuring strain, but they're also sensitive to pressure, contact, or touch. So a clear application of this system is in wearable devices. In our lab, we use this system to print sensory garments, where we print various large arrays of sensors all across shirts and pants, and we use it to perform motion capture of a human using just your clothes. So using that technology, we can use it to improve our athletic performance. We can use it to measure and reduce our risk of injury in the workplace, whether that's in an office and you're sitting and slouching at a chair, or you're on a factory floor where you're constantly lifting heavy loads and twisting your torso back and forth. One of the examples that I like to think about is physical rehabilitation. I've injured myself many times over the years. I've torn this rotator cuff quite a few times. And so as a result, I've had to go do physical therapy. And every time, that process just takes so long. It's over the course of several months. And I think that much of that is because I was always compensating for this shoulder. I would not reach out as far as I should, and I wasn't reaching those target ranges of motion that I should be in order to recover more quickly and more efficiently. Another issue that I had was that I didn't have confidence in my shoulder joint. It always felt kind of shaky and loose, and I didn't want to push myself. I didn't want to re-injure myself. And so if I had had a sensory garment, I could have tracked my progress throughout the day, and I could have potentially reached those range of motion goals or increased my strength consistently throughout an entire period. I wouldn't just rely on going to the doctor's office once a week and make sure that I was hitting my targets. With a sensory garment, I'd be able to know that, I'm not putting myself at risk right now. I'm, using my shoulder in a safe range of motion. And that would have allowed me to recover a little more efficiently, a little more quickly, and perhaps a little more safely as well. So there are applications of this system outside of just wearables. There are certainly plenty of other ways that we can use this system to embed sensing into different substrates, such as carbon fiber or other non-stretchable, non-wearable fabrics. I like to take a step back, though, and just look at the system as a whole. This is essentially a 3D printing system. We have all the same advantages and disadvantages as any other 3D printing system. We can prototype very quickly. We can customize for different clients or purposes. We can reduce material waste by using only the material that's needed for the device in the system. We don't just spend much of it laying that material out over stencils and then peeling away all of that material. But the key advantage of our system is that we're able to produce these sensors, produce these large arrays in a single step.